All right, Zach's here. A few other people are here. I'm going to unmute everybody, but then when the presenters start talking, I will I'll mute everybody but the presenter. There's Phil. Welcome, Phil. And in the chat, I've put the link to the HackMD where I'm taking notes for today's meeting. If you could add your name right in here. I'm Diane Mueller from Red Hat, and I'm one of the co-chairs here. And I know Marcel is here. And we've got 3 speakers today, so we're going to try and get all of them done, and then have Q&A and maybe introductions of all the guests and the attendees here afterwards, just so that we make sure we get all the content in. If that's okay with you, Marcel?
Yeah, I'm good with this. Sure.
Okay. We're also, while people are milling about, Red Hat Summit is coming up, and Marcel and myself will both be there, and we'll be holding sort of an OpenShift Commons meet and greet booth in Community Central. And I think, Marcel, you signed up for an hour, and I'll go look up what hour that was to, if people who are part of the SIG want to come and meet Marcel and myself, will be in the booth at that appointed hour, and I'll go dig up what that is in the next few minutes. But hopefully some of you will get to meet face to face. So a few of you I've known for a long time. So without further ado, I think first up, we have another talk from prophetstor from Jeng. And Brian, if you would like to try taking over the controls, I will relinquish the screen.
Sure.
And you can share your screen, and we'll get going. And while you're talking, there's about 11 people on the call right now. Again, the link to the notes where you should add your name and your affiliation, if you would, is in the chat. And this is the AIOps SIG, and this is our 2nd meeting. And we're really thankful that you're all joining us to have this conversation.
So can you see my screen?
I can see that you are sharing your screen, but I don't have a presentation yet.
Okay.
There you go.
I think I moved it on.
There
Great.
you go. Perfect. All right.
All right. So I'm Brian. I'm an SA over at prophetstor, and I'm going to be talking about Federator AI, which is an AIOps solution for OpenShift in multi-cloud environments. Just to get you guys a little bit of background on the multi-cloud market, it's growing really quickly, right? More and more businesses are shifting their IT infrastructure to the cloud, and it's projected to go from 20% to 40% by the end of 2019. And it's already over $1 trillion US. So there's a lot of opportunity in the sector, and everyone's trying to get a piece, right? So with multi-cloud environments, there's a lot of difficulties with cloud management, both day 1 and day 2. For day 1, there's hundreds of cloud service providers out there to choose from, each with their own price structures and instance types. And if you're a new user that's not readily knowledgeable about these cloud providers, you'll have to do a lot of research on your own. And so just for day 1, you're at a roadblock, right? And then for day 2, even after you deploy your application into the cloud, you'll have to regularly monitor and manage the resource usage based on just to safeguard against inefficiently utilizing your cloud instances. If you over provision, you waste a lot of money. If you under provision, you have a lot of application issues, right? So that's where we come in, Federator AI. We're an AIOps solution that simplifies the cost optimization process for both day 1 and day 2 operations of multi-cloud environments. So for day 1, you just give us the application and optimization policy, and we'll recommend which cloud service provider and instance type to choose. So we do all the legwork for you. You just have to tell us what you want to deploy. And then for day 2, that's where our machine learning AI actually comes in. We learn the resource usage of each pod in your OpenShift cluster, and we provide usage predictions that can be applied to the native autoscalers and scheduler in Kubernetes for much more enhanced resource utilization than the current algorithmic method. Right. So here's some more details about our day 1 deployment. The user will notify us of which application he wants to deploy, approximately how many requests per day, and which policy, whether it's minimizing costs, maximizing performance, maintaining SLA. And we'll recommend which cloud provider and instance type is the most suitable. And if the user wants to just manually deploy into a cloud of his choosing, we just give directly the amount of resources he'll need, just straight up. And then for day 2, this is where our machine learning AI comes in. We learn the future usage of each pod. So if you guys look at this graph here, there's a blue solid line, which is the observed CPU usage, and then there's a white dotted line, which is the predicted CPU usage. And you can see we're about 10 minutes ahead. And the lines are really intertwined, just showing how accurate our prediction engine is at this point. And with these accurate predictions, we can set the CPU request and CPU limit, the green and yellow line respectively, to just the right amount to fit the workload. And you can see how this intelligent scaling can save your resource utilization. And actually, according to our test reports, we improved the utilization by 60%. Okay. And this was a study done by TSL Logic in 2017. This is kind of the use case we're going after immediately. About 84% of on-premise IT environments were over-provisioned. And if they moved directly to the cloud with a direct matching of their resources, they would actually pay more than they currently were paying on-premise. But if they fitted their clouds just right, which we're aiming to do, they could save 36% in terms of monetary value and 60% in terms of resources. Right. And let me just go over to, it's not really a demo. This is just the side-by-side comparison of the native Kubernetes horizontal pod autoscaler and a horizontal autoscaler using our Federator AI. We found benefits in these 3 main categories. We can serve the same workload using 19% less replicas. We can reduce the amount of CPU over limit instances by 61%, and we can reduce the out-of-memory instances by almost 90%. And we have graphs that show all this data, but then the big one here is actually the out-of-memory instances. Basically, every time an application hits an out-of-memory, it stalls out and crashes. So you want to avoid these at all costs. And we definitely, you can see we're the green line. We only have 2 instances here, whereas the rest is just a native Kubernetes HPA. We can reduce these by almost 90%, right? And then just note that this is just the horizontal comparison, but our Federator AI can be applied to the vertical pod autoscaler, the cluster autoscaler, and the native Kubernetes scheduler. So all these different facets of your OpenShift cluster can be optimized using machine learning with our solution. And what's really cool is once we have those usage predictions, we can feed it back into our day 1 tool. And now you have a new recommendation of which cloud provider and instance type to choose. So now your full stack from your resource usage all the way up to your cloud provider is fully optimized using Federator AI. And I'm just going to go over to Operator Hub IO over here just to show you how simple it is to deploy us. We're already listed on Operator Hub.io. You just click us, and all of our details and instructions and how to configure the custom resource is over here, how to install it. And yeah, we have all the links on the sidebar. And that's it. Thank you.
Awesome. That was great.
Great.
Any questions for Brian?
Yeah. Hello?
Ask the question if you've got one, if you got a question for Brian, or shall we save that all for the end?
So this is Marcel. I don't really have a question, but a remark. As far as I know, a lot of your stuff is also up on GitHub, and it's open sourced, and you can plug in different models to the prediction piece. That's still correct, right, Brian?
Yeah. Well, we're gonna do it based on a policy-based prediction. So if you want like a cost optimization, then we'll have the prediction. The predictions will be the same, but the scaling will be based on the policy. So the modeling, I don't think will be changing too much, but I'll have to check with our team if we wanted to change that.
Yeah. But I think from a source perspective and from an ecosystem perspective, this is one of the first complete end-to-end solutions that run on native Kubernetes and OpenShift, which will hook some sort of prediction into the metrics being gathered from Kubernetes. So I think that's a really cool open source solution.
And Brian, is this what you have the operator for in operatorhub.io as well?
The Operator Hub in Operator Hub IO is to manage our lifecycle. So it's basically just sits there, and then we just create a custom resource, and it'll deploy it for the user.
Okay, cool. All right. More about that later. So, in the interest of time, the next person we have up is Phil from MoogSoft, which I have not had a presentation from first, so I'm really actually quite interested in learning more about this. So Phil, you want to try and share your screen? And
sure.
That one in?
Let me see if I can do this and put this into presentation mode as well.
Good luck.
Yeah. Let me see if I can do this. Is all of that coming through?
Absolutely, yes.
Perfect. Super. Well, thanks for inviting us to speak along, and we're super excited to see Red Hat sort of really dive into the AIOps stuff, and it's been an area and a market that at MoogSoft we've been somewhat very early in from the history of the company going all the way back to 2012. We've been long convinced that AI, in the particular guise of machine learning and data science, has got a pivotal role in how people operate the sort of the modern infrastructure. And I can't go forward without sort of making a naked pitch for what's going to happen on May the 15th, which is our AIOps Exchange in San Francisco. And if you've not heard, please Google it and please register. We'd be delighted to have fellow travelers along. So without further ado, I just want to talk a little bit about what we're doing with AIOps to help people with operational challenges that derive principally from the modern cloud residence stack. And my personal journey with this has been pretty lengthy. I've been involved in service assurance and operations since the early 1990s, having co-founded Micromuse and wrote a product called Netcall, and done a bunch of startups in this space, culminating in MoogSoft. And this little eye chart here, kind of gives you a sort of a brief history of time in terms of what I've seen change and morph over that period. And if you kind of go back to the original mainframe era, which was sort of dying out as I entered the market, service assurance was actually done extremely well. And part of the reason for that was, single vendor. It was very, very simple. It was pretty low scale, and change cycles were, glacial, to say the least. Then, of course, we all lived through the distributed computing wave, where this started to erode the ability to to deliver service in a very straightforward way, just because scale and complexity started to enter into the environment with multiple vendors, standards-driven, best-in-breed type approach. And really what's going on is the kind of the latest phase that is, we're all living in the cloud resident, sort of digitally transformed enterprise is spectacularly complex and high scale. We are seeing almost a sort of a chaotic, deployment paradigm where, large enterprises have moved to a fully agile DevOps application development toolchain. So change cycles are almost instantaneous, sub-second, very, very, very large scale, and it requires something very different to be done. And this is kind of a sort of almost a Dimbo slide in a lot of ways, just to sort of punch the point home that in the yesterday data center, if you were writing an application, you wrote an app to run on a specific operating system to run on an actual physical server. There are 2 to 3 interactions between those 3 components. You have to worry about making sure the right version of the operating system, the right version of the hardware, the app is built in the right way, the app is built to optimize the bare metal. But still, it was pretty contained. Then you look today, and actually this is a slice through our cloud in terms of how we deploy our application in. You know, the app is deployed by Jackson, is configured via Helm, that is driving Kubernetes, that is driving Docker, that runs on VM, that is controlled by a hypervisor, that runs on our open system, that runs on bare metal, that belongs to Amazon, right? And, you know, all of these various different interactions and, you know, the dependencies therein, you know, drive 2 orders of magnitude more considerations just for one application. And of course, all of this is, you know, as our friends at Federator.ai were pointing out, you know, we're also navigating our way through the whole multi-cloud and instance management world as well. Net is the complexity is a complete phase transition step change to what it was before. And the so what about that is, you know, this is there for a reason. And the reason is this digital transformation where, you know, you've gone from organizations being able to happily live in the world of a much more regulated economy where, say, a Wells Fargo competes with a Bank of America, competes with a Citibank, whereas now they're having to compete with digitally transformed startups. And this is across every segment, every part of the economy, and it drives a step change in how you manage service. And, you know, it really comes down to this scale and complexity that is driven by this massive upstage in, you know, the number of moving parts. You know, modern application infrastructure is much more chatty. The number of data points is measured in the billions. The failure modes, you know, goes up into this 10 to 120 number, which we worked out from a large enterprise that, well, it's Yahoo, from a while back, which 10 to 120, by the way, the reason I'm an ex-theoretical physicist, the reason why that number is of interest, it actually is more information that is stored in the observable universe, to give you an idea of how bad it is. And the complexity in terms of what people are having to deal with is hugely significant. So what to do? Well, you know, if you look across a lot of our customers, you know, what they're seeing is this overwhelm by data and lack of information is driving all kinds of consequential issues with the quality of service assurance, the amount of data that help desks and SREs are having to deal with, the amount of incidents that are actually being captured by monitoring, how you proceed to a resolution of an issue that is threatening service is very siloed and very linear, and the net is it's horrible. So what do you do? So this is really the appeal for the insertion of AI and data science in operations. And it kind of stems from, you know, back in the day when things were a lot more predictable and a lot more low scale, you had this kind of state and measurement separation of the world, where you could analyze the system that you were monitoring, work out what the potential failure modes of that system were, monitor for the occurrence of those failure modes, act, and then sort of continue to do this in a continuous cycle. And, you know, the time around, if you like, the orbit of that left-hand circle was a lot faster than the change cycle of the system that you're monitoring. And in any case, the scale of the systems was such that you could take this rules-based approach. Well, you know, in the modern world, in the modern stack, you know, you can't do that. It is so complicated that there isn't the ability to analyze for potential failure modes. You can't work them out. It is too complicated. So you can't go through this rules model-based approach to monitor for the known failure modes. You really have to combine state and measurement and use the data that you're getting from the monitored systems to give you indications of where you know, there may be service-threatening impacts, and allowing you to have a much more sort of fluid approach to doing it. So long story short, you've got to use techniques of data science to look for, in the monitored events and metrics from your systems, the clues as to where service may be being compromised. How we do this at MoogSoft, what our incarnation of this insight is really a pipeline of algorithms that starts on the left-hand side with we take anything, we take application logs, We take metrics from Collect D, Stats D. We take traps. We take indications from underlying management systems. We really don't care. We use a bunch of information theoretic algorithms to suppress noise, because, by the way, most of that data is junk and useless. And then what we're really doing is we're looking in those synthesized flows for groups of self-correlated events that indicate that there is an underlying causal thing that has occurred, which has caused the pattern of alerts to be sent to us. We mine that data for these groups of alerts. We call them situations. And because we're extracting this entire narrative of the impact, we're able to take a collaborative approach to inviting people into a virtual incident war room to try and sort of remediate the thing, automatically trigger automation, and then mine the interactions for insights, for future occurrences. And I'm just going to cause the animation to finish. This is a slightly more detailed view of it. So what it really boils down to is sort of 4 pillars. Entropy is the information theoretic algorithm that we use to try and eliminate the noise. This correlation, this grouping, is combinations of unsupervised machine learning and supervised machine learning. We can take indications from time, topology, and text in the data to form these clusters of alerts. We then have a series of information theoretic and supervised machine learning algorithms to look for root cause inside of those groups of alerts. Some of them are neural net driven. Some of them are using terms that you might not be familiar with, vertex entropy, which is actually fundamental research that we did at MoogSoft into how you can take hints from interrelationships of entities to look at where you're more likely, where the high likelihood is of a service impacting incident to arise from. So there are some peer-reviewed journal articles in and around that. And then outside of that, once we have this collaborative war room, we're looking for things like situation similarity, that's cluster similarity, to drive prompting, remediation hints, and to accrete a sort of a living runbook, if you like. If there's anybody that's British on the call, I always chuckle when I see the little bottom right-hand icon, which is supposed to be a brain, but looks like a kind of a Graham Souness wig to me. But anyway, think of 70s permed hairdos. Right, now, why am I not getting any joy here from my computer to be able to flick on?
You trying to swap into a demo, or?
No, I'm trying to move the slide on, but it's kind of not really.
Perhaps you paused your animation and it.
There you go. That's fine. There we go. Let me just get back to this. Are you getting those slides?
Yes.
Okay, perfect. All right. Apologies. We like to think of ourselves as an AIOps leader, and I'll give you a little bit as the reason why we made that claim. We've been at this since 2011. We've filed 50 plus patents, been granted. I think 14 was the number on Friday, and there's about 20 that will grant this year on top of that. We've raised about 100 million in funding since 2012. Goldman Sachs, Cisco, Redpoint, Wing. We're about a year away from being cash flow generative. We'll never need to raise finance again. We're on our way to scale. About 150 of the Fortune 2000 use our software. The team is comprised of a bunch of folks that really have been here before. This will be my third at scale company in this space, and we've got leaders from Splunk, Qualys, AppDynamics, and other businesses in there as well. And if you look at the breadth of the IP that we've built, I mean, this is just a vista across places where we have either both filed a patent or produced a peer-reviewed paper that has generated IP that is in the product. So everything from alert significance, timestamp patents, text value similarities, use of topology, use of entropy of graphs, use of deep learning across the correlation engine, feedback, and root cause kind of form part of our platform. And that's it for me. Again, I'll just say if anybody is welcome to come join us on the 15th of May in the Four Seasons. Just hit our website; it's pretty prominent. Any questions? And thank you for listening.
What city was that event in?
San Francisco. Our HQ is in Levi Plaza. We're doing this on the Four Seasons on Market Street.
Okay, cool. If you want to post that to the SIG mailing list, I'll put that link in the chat as well, so you can post that for other members.
Perfect. I'll ask Gabe, who's from our product marketing, to do that for me, and we'll definitely do that. But thank you.
Perfect. Anyone have any questions for Phil while we're here? And while we're waiting, Zach, you want to queue up your presentation?
Yep. Can everybody hear me?
Yes, we can.
Perfect. Share my screen.
Come on yet. Here it comes.
You see my screen? These slides?
Yep.
Perfect. Okay. So my name is Zach, and I work in the AI Center of Excellence under Marcel, the AIOps group. And I'm currently the lead for the log anomaly detection project. And I wanted to go over and present some of the things that we've been building internally. So first, the use case. So we're building this log anomaly detector to help our internal customer with root cause analysis. We built it with unsupervised machine learning to identify the anomalies. We found that with machine learning, it's more of they give you a probabilistic answer rather than a deterministic answer, where probabilistic is generally saying that there's a percentage of being correct, and there's a possibility of having false positives. And we'll talk a little bit about how we built and designed some things to tackle those challenges. So our architecture, we run on Kubernetes, and we have basically the core component, which is the log anomaly detector, which pulls log data from Elasticsearch, trains, and then produces two models. I'll talk more in depth about the model part, but for now, I just wanted to kind of give a high-level overview of the system. And then once the models are trained, there's inference. The inference step also basically tags anomalies that are flagged as anomalies, and we store that in a fact store. We also generate a prediction ID, so we can reference it later. And then which I'll talk about more in the next slide, which is about more in depth about the fact store. And then we have some monitoring and dashboard tools. We're using Prometheus and Grafana to get a dashboard to see the feedback that we're getting back from the fact store, as well as the metrics that are being generated from the model training. So we also in the inference step, we also send out messages to Elasticsearch, which triggers a alert to be fired off and an email sent to the user. And in that email, we embed a link, a hard link, where we use that prediction ID that was generated in the email. So when that user says, okay, this is not an anomaly and this is false positive, they can report that and give us feedback on that. And that link would lead to this particular page here, the fact store, where the anomaly ID would be in here, specify if it's an anomaly or not, and then you put some notes if you want to give us even more detail on why it's not an anomaly. And that's the high level overview of the system. we'll go into more in-depth detail on the models and the fact store as well. So the system itself is basically a Python program. It's CLI. You can specify if you just want to train, or if you want to train and do the inference all in step together. You can provide a config map or a YAML to inject into the program, or you can specify environment variables. Both options are supported, and you can either pull data from Elasticsearch, or you can pull data from a local file, and then the sink that you would write to would be either Elasticsearch or a local file. Again, we may we're actually looking at maybe trying out Kafka next to try to see if we can get some more performance out of it. So the fact store, came about because of because folks were getting basically predictions that weren't necessarily right. So we needed human feedback to verify, is this really an anomaly or not? And I'll talk a little bit more about the SOM model itself. So I can't take the credit for this whole system itself, as I had a great data scientist on the team, Michael Clifford, and I had an awesome architect, Wojciech Pawlin, who also were involved in the design of the model training of the SOM model and the overall system. I've added the fact store, which was an additional component to this system. So I'll talk a little bit about the model training part. So there are two models. There is a word-to-vec model, and the word-to-vec model does the machine learning. And basically what it does, it learns the probability of words occurring with each other. We're using it in a very kind of unconventional way, but basically it's kind of like a pre-processing step. Basically verify, basically convert the raw log messages into vectorized representations. And once we're done with that, in the training step, the next thing that happens within the training step is we generate another model called the SOM model, self-organizing map. And what that does, it compares the vectorized representation of the words in the inference step, and basically it would basically train the model, and you would measure the distance of each inference message to the different nodes on the map, and then determine how like or unlike they are to the nodes on the map. Basically, it generates a real number. If it's normalized, it would be between 0 and 1. We have a threshold value. It's configurable. But basically, let's say consider if it's 3, 3 times the standard deviation plus the mean. That's an example of how we're calculating the threshold value. And then this is a standard way to determine if it's outside the bounds of normal behavior. If it's outside of the bounds of normal behavior, we'll flag this as an anomaly. And anything that we would make sure we record it. Another additional thing that we have within the fact store is we use a Bloom filter to store the IDs of the predictions that were basically or the messages, and then we want to kind of check, has this message been seen before, when we're has this been reported as an anomaly, and then kind of try to prevent the user from getting duplicate emails and messages. For if he reported this was an anomaly, they should never get an email again. The next step after this is to pull in that data and then retrain the model with the false positives. and that's still in development. And that's something we're working on, improving our model on. And yeah, so pretty much that is the flow of how this system works. The next thing I'm going to show you is a live demo, because I think slides are cool, but what's cooler than a live demo? So I've prepared an environment here for us. So I've deployed. So the database that's being used, we're using SQL Alchemy, and the database we're using is MySQL. Then we have Grafana and the prophetstor, which is a Flask application which connects using SQL Alchemy, and you can if you choose not to use MySQL, you can use Postgres, you can use other different databases. But for us, we just wanted to try it to use MySQL, and that works for our use case. So the trainer here is basically, you can kind of look at the system training, look at the pod itself, the log anomaly detector. We can see that it did send it recorded some anomalies, and it sent some anomaly was found. This is the score that they found. The data scientists can also look at a Grafana dashboard, a little bit easier to look at. You can see how we're performing in terms of the system itself, and also you can kind of view some of the log messages that were recorded, the prediction ID, the score, and then the internal customer can give us feedback over here. So I'm gonna go and let's say I got this email. This was the particular prediction ID that was emailed with a link on in it. We would use query string, but then it would auto fill these values here. And basically, I would say, is this an anomaly? False. And why is this not an anomaly? Because it is just wrong. And once I submit that feedback goes in. It's now in the dashboard. We can see this anomaly wrong, and that's it. And pretty much we iterate through this and continue developing. And that's pretty much it for demo. Is there any questions? Anything that anybody wants me to dive into more in depth? I'd be glad to take any questions.
Not seeing any questions yet, but there really ought to be questions. And I'm guessing that the internal customer is perhaps OpenShift Online or OpenShift Dedicated. Am I right in my guess, or close?
So we have this internal machine learning platform where we have OpenShift and we have more components like Elasticsearch, Kibana, as well as Logstash and Kafka, and some systems are deployed up there, and their logs are streaming through Kafka and then into Elasticsearch. Some customers would have a requirement for some machine learning, and then we deploy this service as a service that they would utilize internally.
Yeah, so the internal customer, Diane, I think that was also your question, is a team within Red Hat that is maintaining build pipelines for containers, and they are using this tooling to identify anomalies in logs of their deployed system. And they are running on an internal deployed OpenShift instance. So basically, you could deploy the same setup that Zach just highlighted to any other team that also runs on top of OpenShift. And I think that's where we're trying to go from a prototype that Michael Clifford did as his internship last year. Then Vajek took it and sort of productionized it, and now we're trying to actually apply it to a running customer. And it's, again, all open source. You can find it on GitHub and deploy it for yourself. Obviously, it has some prerequisites to set up, so it needs to be on top of OpenShift, and it needs access to Elasticsearch where the logs are stored. But other than that, it's an open source project. And we're also in the process of collaborating with a Czech University in Prague to extend at least the research part of it. And it's coming out of the CTO office of Red Hat, so it's no way a productionized system, but it's some of our internal research topics that we're doing.
Zach, can you post the or go to perhaps the GitHub repo with the source code in it?
Yep.
That would be great. So, are there any other questions, thoughts from folks on the call for Zach or for Brian or for Phil while we have them here? And if there are other topics you folks would like to hear about, we will be meeting again in another month post Red Hat Summit and KubeCon, so there'll be lots of busyness in between. So if you've got topics that you learn about there that you want to talk about afterwards, just ping Marcel or myself and we'll get them added to the next agenda.
Just one quick thing, sorry, it's Phil. I mean, that comments about the collaboration with the Czech University, I mean, we are very active collaborators with academia, so it'd be kind of interesting to connect post the event about that, just to see, if there's any opportunity for crossover with the stuff that we do.
Yeah, sure. And it's all going to happen on that very GitHub repo where we try to post the datasets. And actually, that's a good cue for maybe one of the next topics. So one very dear topic to my heart is that there's like a lack of public datasets where you could do some research on operational data. A lot of this data is internal because it has some identifying, identifiers to your internal data center and the stuff that you're running. But there's nothing out there which would give us like a stream of log files or even labeled data for metrics, like you would see it in the usual machine learning space where you have Kaggle and all sorts of competitions. So I'm really eager to build out the collaboration amongst folks here on the call to sort of curate data sets and drive interest also from academia to apply their magic tools and wisdom to those data sets that we can bring to the table as operational folks. So yes, Phil, I'm really keen to collaborate on that.
Perfect, because I mean this is near and dear to my heart as well. I mean, if you think about like sort of graph theory, you've got the Snap data set, the Colorado Icon data set, which is pretty well known. The IEEE have just created this new way of curating these things, so they get a DOI number as well. So it's very good from an academic research perspective. So let's connect up afterwards. There are issues around anonymization that are well understood and well known. But I'm sure between us, our customers, your customers, we can maybe work something out.
Yeah, awesome. And I actually have a question to your presentation, Phil.
Cool.
So it seems that your setup is pretty much agnostic to what kind of operating systems and what kind of environment you're running in. Or do you have some sort of preference, whether it be a virtual machine environment or a containerized environment? I'm not talking about where you run your software stack on, the MoogSoft stuff, but the environment that you are monitoring and applying your actions to.
Yeah, we really don't have, kind of any inbuilt impediment for one particular environment or another. What I will say is obviously, what tends to play is, where we go where we want it. And, today, an awful lot of that is very much sort of cloud focused and, new stack focused. So we tend to work a lot with, managing the hypervisor, managing Docker, managing Kubernetes, managing the modern compute stacks, so the various different elements you tend to find in it. The application performance monitors tend to be a very common source as well. But that's really more a focus of where we've been rather than where we could go.
Okay, great. Yeah, and I actually would love to see a hands-on demo at some point. Maybe we can connect to that, and maybe even to a Kubernetes environment, because I think that's what most of the folks here on the call are interested in, and most of the people that will see it not live but posted on the website. I think we have more people viewing these recordings afterwards than actually live, I guess. And as they're posted in the context of the OpenShift comments, I think that's where the interest of most viewers will lie.
So the easiest thing we could do for you is if you're in San Francisco, drop by and we'll demo it running our cloud environment, which is Kubernetes based.
Oh, perfect.
Oh,
perfect.
Yeah, I would love to, but I'm too far away. I'm based in Germany, so it's not not so close.
So we have a big office in London, which is a little closer.
Yeah. And
of course, there's nothing stopping us doing something remote. Although I'd love the invite to Germany. It's, but,
are any of your folks going to KubeCon in Barcelona?
That's a good question, really, for our marketing people rather than me. I don't know.
Okay, so if they are, definitely let us hook us up, because there'll be a lot of Red Hatters there as well. It would be lovely to have that demo done virtually, because that's really the goal, is to try and capture some of this content and share it with as many people as possible.
We can definitely arrange that.
Okay, awesome. So we do have a bunch of upcoming events, and I know there'll be at least a lot of Red Hatters at them, and hopefully some other folks from different AI SIG meetings. ODSC is coming up this week, and so there'll be a lot of people in Boston, and then right after that is Red Hat Summit, and I did dig up the time. It's 2 p.m. on the 8th. If you would like to meet everybody in person, you can find out what Marcel looks like in person and myself, and come hang out at the SIG Meetup in the Meet and Greet booth in Community Central on the expo floor. And as Phil, I think it was, that mentioned it, the AIOps Exchange is happening in San Francisco, and there's a link in there for that. So if any of you are going, please do connect with each other, because that's really the goal of the SIG, is to get everybody interconnected and aware of the work that each of us are doing in this space. And,
Great.
If there's anyone else on this meeting that has topics that or projects they're working on, or initiatives they're working on inside of Red Hat or outside of Red Hat, please do propose them. And if any of you want to work the booth at Red Hat Summit at the Expo Hall, let me know. Plenty of space and hours still open on either the operators or the Commons Kubernetes one, or the meet and greet space. So let me know. I'm always looking for people. And it's a great way, the Commons meet and greet one is a great way for folks to show off what they're doing for Commons members. So, anything else you want to add, Marcel, or anyone else?
No, I'm good.
All right. Well, thanks again for all of you for coming. We'll post the video of this and the notes on the Google group. If you haven't joined that yet, please do. The link is just AIOps on Google Groups. I'll throw that in the notes too here. If you haven't seen that, if you haven't joined that, that's where we're using. It's a very public forum, so just be aware of that. And we're just happy that you came and listened, and really glad that both prophetstor and MoogSoft and Zach shared your stuff today. Very helpful and enlightening. So on that note, I hope to see lots of you at Red Hat Summit, and hope you have a great time at ODSC, Marcel, and everyone
Thanks,
else.
yeah.
Cool.
Perfect. Great.
Okay. Thanks, Diane, for hosting this.
No worries. Great.
Yeah.
Thanks.
Cheers.